All right.
Okay, now on live. And maybe you can stop sharing the screen, Vishal.
Yes.
And yeah, Brown, please.
Oh, okay. So hi everyone. So we have two speakers today, and today's topic is about the no report paradigm. And the first speaker, Yen-Kuang Chen. So he was previously a master student in my lab, and now he's working as a research assistant. And he will be talking about a project that he finished as his master degree project, which is about whether P3B is really reflecting consciousness or not. So Yen-Kuang.
Maybe you guys,
Okay.
if you are doing SNS, you can probably advertise that it started now.
Okay, so can you hear me?
Yes.
Okay, everything's good. Okay, everything works fine. Okay, then I just go on. Hello everyone, and nice to see you. So this is the topic I'm going to talk about. P3B does not reflect perceived contrast. And this study was just published on eNeuro this month. So I put the DOI here, and I also made a QR code for it. So if you're interested in the detail, just scan it. Okay, here we go. We are going to start the story with research about NCCs before, and guess most of you are not strange about this word, right? So NCC is an abbreviation of the neural correlates of consciousness. So many studies about NCCs before used contrastive analysis method to get the result. And typically, the method was just like this, comparing conscious and unconscious brain activity. However, there are some problems with this kind of method. The contrastive analysis method relies on defining whether participants are conscious of the stimuli by asking them to subjectively report it. And it is this subjectively reported activity. So ideally, the only difference between these two conditions should be conscious or not. However, many peri-perceptual processes may take part in, may confound the NCC, since the participants are required to report their conscious experience only in the conscious condition, but not in the unconscious condition. Hence, to address this issue, the no-report paradigm has been developed. And in the no-report paradigm, participants are not going to be asked to report whether their conscious perceptual experience, whether they see the stimuli or not. And because they don't have to make a judgment about their conscious perceptual experience, the NCC should be less confounded. So no-report paradigm became widely adopted in recent years. For example, this is a paper published by Cohen and his colleagues in 2020. And they try to reinvestigate whether a potential NCC candidate, P3B ERB component, reflects perceptual awareness by using such no-report paradigm. So in this study, Cohen and his colleagues used both the traditional contrastive analysis method and the newly no-report paradigm. While participants were under the report condition, which is the traditional method, participants are asked to report if they detect a stimuli. So you can see the upper part figure. There is a P3B amplitude, right? This is the result when the participants saw the stimuli. On the other hand, let's look at a gray curve in this upper part figure. There's no P3B when participants didn't see the stimuli. Next, while participants were under the no-report condition, which means that no matter what, participants are not going to be asked to report their perceptual content. Let's see the bottom part of the figure. You can see no matter whether the participants saw the stimuli or not, there was no PCB. So based on these results, Cohen and his colleagues concluded that PCB is not a signature awareness per se and is instead more associated with post-perceptual processing. So the status of PCB as a potential NCC seems to be voided again. But let's go back and discuss Cohen and his colleagues' study first. So in this study, they found PCB in the report condition, but not in the no-report condition. And they argue that the only difference between these two conditions is reportability. And they also assume that participants had identical consciousness of the stimuli in both conditions, because their participants could almost correctly record all the stimuli in the incidental memory task after these two conditions. However, it was being shown that perceptual awareness could be modulated by attention. As we just mentioned at the beginning, right? Participants should have different attention states in these two conditions separately. So we propose the possibility that participants would have a degraded consciousness of the stimuli under the no-report condition compared to the report condition, because their attention is diverted away from the stimuli. And if it is true, then it would be uncertain that the disappearance of PCB in the no-report condition is caused by reportability. It could also be caused by the degraded consciousness. To address this issue, we propose to directly measure participants' perceived contrast to the stimuli in the incidental memory task. So we have two questions follow up. The first question is, do participants experience degraded content of consciousness in the no-report condition compared to the report condition? And if it is true, then we have the second question, which is, does the degraded consciousness correlate with the correlate with the change of PCB amplitude? If yes, then we would say that PCB still reflect consciousness. Otherwise, we will support Cohen and his colleagues' conclusion that PCB does not reflect consciousness. Okay, so is there any question so far? So if not, let's start talking about our first experiment. So the left part shows the procedure of our first experiment. As you can see, there was 4 phases. And in our study, incidental memory task on object identity were changed into incidental memory task on visibility. And the right part shows the procedure of each trial. So in the first 300 milliseconds, only the fixation point was presented. Then the stimulus or blank will show up for 33 milliseconds, which is 2 frames under 60 Hertz refresh rate. And then followed by a 1.3 IDI, a 1.3 second IDI. We have 64 trials, half of them presented with stimuli and the other were blank. So as you can see, the stimuli were those gabor on the screen. And they could be 45-degree incline or 135-degree incline. Also, in some of the trials, the green ring will randomly show up at a randomly time point in each trial. Our participants were instructed to ignore those gabor grading and count how many times they saw the green ring. So after all these 64 trials were completed, participants needed to report the pop-out times of the green ring. Then they moved to the second phase. And in this second phase, we used the incidental memory task on visibility to measure if the conscious level of the stimuli was degraded. To be more specific, we made our participants see the whole procedure of the previous phase again. However, there's one thing different, which is the contrast of the double grading. So we asked them to adjust the contrast to become the same as what they saw in their memory. Okay. Then they moved to the surface, and pretty many things were just the same: 64 trials and 32 with stimuli, 32 with blank. And for those stimuli, 50% of 45-degree incline, 50% of 135-degree incline, including those green ring, still randomly show up in some of the trials. So the difference is was that a 3 ASC question follow each trial. And in this 3 ASC, participants need to report what they saw in each trial, maybe blank or 45-degree inclined gabor or 135-degree inclined gabor. Also, they didn't need to count the pop-out times of the green ring in this phase. And the fourth phase, we had another incidental memory task on visibility to make participants report their perceived contrast of the gabor under the report condition. And just like the second phase, to measure if the conscious level of the stimuli is degraded. Okay, and next, we made a comparison between the results of these two incidental memory tests on visibility to see if the perceived contrast degraded more under the no report condition than under the report condition. So before showing you the results, let me remind you our question first. So the question is that, do participants experience degraded content of consciousness in the no report condition compared to the report condition? Okay. So you can see the y-axis here, which is the contrast level from 0 to 1, or you can convert this from 1 to 100% on your own. Okay, here's a significant difference between these two bars, right? And actually, the participants always perceive a 0.6 contrast level in the whole study, including the follow-up experiments we are going to talk about later. And you can see participants reported a number pretty close to 0.6 under the incidental memory test after the report condition, which is the red bar. But for the no report condition, the contrast level dropped to around 0.3. So we got a positive result, which supported the possibility we proposed that participants did experience content of consciousness, a degraded content of consciousness in the no report condition compared to a report condition. Okay. However, there was a possible confound in this design. Maybe the stronger visibility in the report condition is only because the second incidental memory task on visibility was no longer incidental. So participants should expect they would have the same task while they were in the report condition, because they would just got through the first incidental memory test, right? So if it is true, maybe participants getting a better performance for report condition was simply because they pay more effort to remember it. So we did a follow-up control experiment to see if this possibility existed. And in this control experiment, we replaced the no report condition with the report condition in the first phase, and all the rest were just kept the same. In other words, we do the same task for 2 times. And again, compare the result of these 2 incidental memory tasks on visibility. So if there is an order effect, we will see a higher contrast in the second incidental memory task on visibility. And in contrast, if there's no such order effect, we would see similar contrast level in both incidental memory tasks on visibility. Okay. And here is the result. So as you can see, no significant difference between these 2 bars, suggesting that the different perceived contrast between the no report condition and report condition was not caused by the order effect. Okay, so let's make a quick conclusion of the experiment 1. In experiment 1, we got a yes answer. Participant did experience degraded content of consciousness in the no report condition. Now let's look at experiment 2. So in experiment 2, we had 6 conditions, and the former 4 were identical to experiment 1. And we added another 2 phases to directly manipulate the clarity of conscious content for observing if this manipulation will change the amplitude of PCB. So before showing you the ERP results, let's see the result of the behavioral part first. So just as what we did in experiment 1, we made a comparison between these 2 incidental memory tasks. And again, we replicated what we got in experiment 1. Participants experienced degraded content of consciousness in the no report condition compared to the report condition. And the gray area, not this slide. Okay. And next we compare the ERP under the no report condition to lead under the report condition. Okay, so you can see here is the gray bar, right? The gray area indicates the PCB ROI. And this figure is the result after we average all the microvolts within the time window. So if you still remember what I showed when we were talking about Cohen and his colleagues' study, the pattern is basically the same. There was PCB when participants saw the stimuli in the report condition at the right figure, right part of the figure, the red curve, and no PCB in the rest of the conditions. So it basically replicated the result in Cohen 2020. And why I say basically? Because we got different latency and direction of PCB. But this is a trivial thing because it could be caused by maybe environment or time point or even equipment. Okay. And next, here comes the main point of our experiment 2. We examine whether PCB is different between the report condition and the lower contrast report condition. So the only difference between these 2 conditions was that participants received a stimuli with a 0.6 contrast level. Yes, always 0.6. And they received a 0.3 contrast level in the lower contrast report condition. So report condition is 0.6 and lower contrast report condition is 0.3. Again, before showing the results, let me remind you of the question first. The question is that, does this degraded consciousness correlate with the change of PCB amplitude? So if we got yes, it would be seeming like PCB still reflects consciousness. Otherwise, PCB does not reflect consciousness. Okay. So the right part figure is the ERP result of the lower contrast report condition. And you can see there's a PCB amplitude within the gray area, right? This is the condition that participants saw the stimuli. On the other hand, no PCB if they saw blank. And next, we take the average amplitude of the lower contrast report condition between 300 and 400 milliseconds. Take the same things from the report condition and then did a 2x2 ANOVA task. We only got the main effect between blank and stimulus. The main effect between higher contrast and lower contrast was insignificant. The p-value was 0.16. So there was no interaction either. So in our experiment 2, we got a negative answer. PCB amplitude wasn't influenced by the degraded consciousness. Okay. Finally, let's conclude the whole study. So in our first experiment, we tried to investigate whether participants experienced degraded content of consciousness in the no report condition compared to a report condition. And we got an affirmative answer that the consciousness of the stimuli is different between the no-report condition and the report condition. And furthermore, this result is not caused by the order effect, but more likely caused by attention. And followed by the first result, our second question is that does this degraded consciousness correlate with the change of P3B? And in our second experiment, we got a negative answer, which is that P3B does not reflect perceived contrast. So this current study strengthens the claim that P3B is not a signature of perceptual awareness, but is associated with post-perceptual processing. Okay, and here is the acknowledgement. Thanks to all the people on the slide, and thank you. Should I leave the? Should I stop sharing screen, or I just keep over?
Right, thank you, Yen-Kuang, for your presentation. I think you can keep your slides for a while you take questions. All right, we're happy to take any questions or comments if you have any.
Then, if nobody else, then I'll ask maybe. So that's a very clever design and nice, interesting result. And I think it may become a bit too getting kind of narrower, but also I think it's a good thing as a sort of progress of the consciousness research that about the no-report condition, there are several possible mental states that subjects can have, right? Like, your...
Yes.
Yeah, like in your individual memory incidental effect for the experiment 1, there are some subjects who reported, experienced contrast to be either high or more similar. I think it's page 15.
Page 15?
Yeah.
Oh, this one.
Right. Yeah.
Okay, let me open.
Which I thought very interesting, and also, it's also, in a sense, kind of promising, because if I'm a subject under the no-report condition with no expectation about, this kind of incidental stuff, then I could be either not reporting, but paying attention to the display all the time.
Yes.
Or thinking about something else completely, like in the state of the mind wandering, or not even looking at the display, or sleepy in the sense of, local sleep or micro sleep or something like that. So do you have any idea how to tease apart this kind of possibility within no report conditions?
I think we just got a similar result that participants didn't put pretty much attention on the stimuli, right? And I haven't come up with a property solution for it. Maybe we can change the instruction or something like this. I don't know. It's pretty interesting, yes.
Or maybe, we could look at the local sleep frequency during the no-report experiment or something like that.
Oh.
I mean, you have the data, right?
Yeah, it seems that another possibility is that you can go back to check what these subjects are doing, right? So, for example, if they have high perceived contrast, now after the experiment, maybe you can ask them, well, what were they doing during the experiment, and maybe you can get some subjective description about what they actually did.
Oh, okay. Then, yeah, we didn't have such things. Maybe we have to rerun another task for this if we want to go to this.
Okay.
Okay, thank you.
All right, Rerun, do you have a question?
Yeah, I have a question. So Again, well, thank you for the lecture. What I wanted to ask is again, taking again about this slide and the slide that came later on. I don't remember the number of the slide that
Okay.
shows the order results.
All the results. Okay.
Yeah, but let's start with this one.
Okay. Start with this one, right?
So maybe I didn't see it correctly, but so if I just look on these results, you compare the no report and the report condition, and you say that there is some kind of a p-value difference. But when I look on the result, what it looks to me is that there were a couple of subjects with that reported first a very low contrast level, and then reported a very high contrast level, versus some subjects that were reporting high contrast level and then low contrast level, and another group that didn't change much. And the question over here is again about individual differences. Whether what you are measuring here is a group difference, and from that you try to infer a group level consciousness state, or whether you can at all do it because it's an individual property and not a group level property. So wouldn't you say that the difference should be first you have to sort the people according to the difference that they have, whether it was positive or negative, and then look on differences between group of people or something like that? And coming back to the next slide, if I looked about it correctly, and it was fast. I didn't look at
This slide, right?
carefully, but it looks to me here as if there is a difference between the variability of what is going on over here versus the variability of what was going on previously. So I was wondering, how do we interpret this kind of differences, and if you looked on it?
Yes, I'm not sure, but I will try it. Okay. So you can see in this figure, the trend is very clear. So not very much participants dropped the report contrast level in the report condition. Basically, the trend is just go up, right? From the no report to report. So maybe we can.
I'm not sure about that. I think that there are different group of people over here. I think that there are a group of people that increased, a group of people that were about the same, and a group of people that decreased.
You mean? I'm not sure. I'm not sure what you're just talking about. I think maybe we can explain that people in the report condition report lower contrast level as maybe their attention stable to the stimuli. The attention to the stimuli was lower than other participants. So they are not really focused on this study, I guess.
So I think one way to address Yaren's comments is that you can probably sort your data based on you can sort the data based on whether the perceived contrast is increasing or decreasing between the two groups, right? So you can probably have three kinds of people. One is that, well, they have low perceived contrast in the no report and high in the report, or similar, or the opposite, right? High in no report and low in report. And then you can analyze the ERP component separately for these different groups to see if there's a difference between different kinds of people, so that you can address Yaren's comments.
Yeah, but I'm not sure. I don't really think there's an individual difference. People perceived lower contrast in the lower report condition, and some people perceive higher contrast in the no report condition. I think maybe their attention status is different. For me, I'm not sure. Yeah, but maybe we can do that to check if it is existed.
And Brown, there was a comment on YouTube, which I
Oh,
pasted to you on chat.
okay.
Okay,
Wait, I couldn't. Wait, okay.
Maybe should I read it then?
Oh, I found it. Okay. So the question is, I would be interested in knowing how the term no report paradigm is equal to or different from objective measure of consciousness.
objective measure.
So did you hear the question?
Yeah, I still trying to understand it. Objective measure. Can you say that again?
Yeah, so the question is, well, you're doing the no report paradigm, right? Is this
Yes.
the same or different from the so-called objective measures of consciousness?
Oh, okay. So it should not be, right? Because in the stimuli presented phase, the participant will just receive the targets. So they don't have to make a judgment about the stimuli. They don't have to answer if they see the boy or not. So I think in this no report condition, there was no such objectively judgment to their consciousness state. And this activity happens on the incidental memory task on visibility, but I don't think this is just. But for this task, it's only to check if the participant perceive the same contrast to report condition. So yeah, I think pretty much not different, pretty much different between these two.
Okay, and there's another questions on YouTube. The question is, did you only analyze participants' reported contrast? And
Oh. Okay, yeah, we have analyzed all those things. So go back to the. Yeah, you can scan the DOI here. Scan the QR code here. So we also analyzed the correction and to make sure if the participant did saw those targets, to make sure they can correctly report what they saw. And those correction rates were just pretty high, so it supports that it supports that participant know what they saw on the stimuli presenting phase. So yes, you can go back to check the paper here.
Right.
Yeah,
there's a follow-up. So a follow-up question is, well, did you try analyzing the difference between reported contrast and the actual contrast?
Actual contrast. Actual contrast is always 0.6.
So I guess the question is, well, given the same contrast, right? Given the same actual physical contrast, or sometimes, well, participants would perceive as a higher contrast, sometimes lower. And do you see any difference when the perceived contrast is changed?
Okay, so this is the limitation in this design. We cannot simultaneously present the stimuli and collecting their perceived contrast. So we always say it is an incidental memory task. And I think this is a pretty interesting question because yes, it would be much better if we can test this perceived contrast simultaneously.
I mean, even a post hoc, based on the reported incidental memory, visibility rating, you could look for the neural correlates that correlates with the reported, contrast, right?
Okay.
It doesn't have to be simultaneous, assuming that, eventual contrast that were reported is faithful, you can see whether, particular ER components are related to that kind of reports or not. Although I
Okay, so
suspect that it could be quite noisy. You may need more subjects
Yes.
possibly.
Yes, I can try it. We'll keep all of them. Thank you.
And now, so there's the last paragraph you pasted. Is this a question or?
Yeah, question from YouTube again.
Okay, so there's one more question, the last one. So degraded consciousness might not necessarily mean less clear perception, but less faithful to reality. So people who reported much higher contrast could also have degraded consciousness.
Yes. So we say more degraded, right? Oh no, full consciousness. Yes, it is possible. Maybe even under the report condition, the results in the memory task may be still a degraded result, but it degraded less than under the no report condition. So
so maybe in the future, if you want to test it, we should let the subjects report the exact content of their perception, right, rather than just higher or lower, and maybe make some description about what they actually perceive.
Yes.
Possibly related to this, you could also look at the degree of the variance in ERP within the no report versus report condition. If like this comment says, if under the no report condition perception is more variable and unreliable, then you may see that ERP variance may be actually bigger under the no report condition. Yeah, I guess something like that has been probably analyzed in the context of attention, right? Probably.
Okay. I'm not sure, but I can go back to check.
Yeah, I guess that's also potentially you can write another paper out of the same data.
Okay, thank you.
Okay, thanks for all the comments and suggestions. So we're now move on to the second talk. So our second speaker is Dr. Vishwa Kumar. And Vishwa got his PhD from the Max Planck Institute at Tübingen, and where he worked with Nikos Logothetis to study neural circuits of conscious visual perception and cognition. And he has recently moved to Shanghai and set up his lab in the Institute of Neuroscience of the Chinese Academy of Science. And I think today he is going to talk about his recent finding on neural correlates of conscious perception in the primate prefrontal cortex. So Vishwa, if you're ready, the floor is yours.
All right, can you hear me?
Yes.
Great. Okay, thank you, kind introduction, and thank you now and other organizers for organizing and inviting me and giving me an opportunity to present my work today as part of this consciousness talk series. So I'm going to present some of the recent work that we have done related to the neural correlates of conscious perception in the prefrontal cortex using the no report paradigm. So one of my keen interests is actually visual perception, and this is how Hermann von Helmholtz at least described this phenomenon. He said that the sensations aroused by light and the nervous mechanism of vision enable us to form conceptions as to the existence, form, and position of external objects. And he said that these ideas are called visual perceptions. By conceptualization of perception as an idea, he was perhaps referring to the inferential, the predictive, the generative mechanisms that the brain needs to employ in order to make sense of the visual world around us. But there is one inherent issue in studying perception, is that it co-occurs with the sensory input. And this is where multi-stable stimuli help us to disentangle sensation from perception. Examples of which are shown below. For example, the Necker cube or the face vase illusion, or it has been routinely used by none other than Salvador Dali in his paintings. In all these cases, although the sensory input of the subject stays constant, the perception of the subject actually vacillates, and therefore it allows the experimenter to dissociate any neural correlates from sensory input, of sensory input from conscious perception. And the choice of nervous mechanism that we like to study is actually the primate visual system. It consists of a consortium of areas, of more than 30 areas that are distributed across the cortical and subcortical regions of the brain. With so many regions of the primate brain which are processing visual input, our perception is likely the result of dynamic interactions between these different regions which are processing certain attributes of our visual input. And with so many regions involved, can we still study perception at the level of single neurons? And I would like to convince you today that yes, that is indeed possible. And this is where paradigms such as the binocular flash suppression and its variants come in extremely handy. Here I show you the typical binocular flash, what the typical binocular flash suppression paradigm is like. It consists of two different kinds of trials: the physical alternation trials or the binocular flash suppression trials. The physical alternation trials start with monocular presentation, in this case, a face stimulus presented to one eye for about 1 second, after which this stimulus is removed and the second stimulus is added contralaterally. As you would expect, anybody viewing such a stimulus, their perception would be a face stimulus followed by a checkerboard pattern. During binocular flash suppression trials, the first half of the stimulation is actually identical. So a monkey face is presented to one of the eyes, but without removing the face stimulus, a second stimulus is added contralaterally, in this case a checkerboard pattern. And what happens is that it results in robust perceptual suppression of the first stimulus in such a way that the perception now of the subject is actually identical to physical alternation trials, very similar. So it is a face stimulus is perceived followed by a checkerboard pattern. As you can see, comparing the physical alternation and binocular flash suppression trials, even though the stimulation is actually monocular in case of physical alternation, but it is binocular, it is dichoptic, it is ambiguous in case of binocular flash suppression trials. However, the perception is similar, that is, a checkerboard pattern is perceived. Now, what we can do is that at the same time, we can record from feature selective neurons in the primate visual system. So, for example, if I was recording from a face selective neuron in this case, I would show you the activity of this neuron when its preferred stimulus is presented first in gray, and when its preferred stimulus is presented second, the response of the neuron will be in black. And this is a cartoon neuron, just for explanatory purposes. So when a face stimulus is presented first, the neuron fires vigorously, reducing its activity when the face stimulus is removed and checkerboard pattern is presented during physical alternation trials. If I were to change the order of the two stimuli such that the monkey face was presented second, you would expect that the neuron fires later. The differential modulation that the neuron shows to its preferred versus non-preferred stimulus is denoted here in yellow as the strength of modulation. Now, interesting things happen during binocular flash suppression, and at least two things can happen. Given that the face stimulus is present right in front of the monkey's eyes, the neuron could continue to respond to the sensory presence of his preferred stimulus, such that the neuron continues to fire as long as the monkey face is present in front of the eyes. If the order of the stimulus is changed, the neuron just fires later. Alternatively, the neuron could be modulated by the perceptual presence and absence of its preferred stimulus. So during binocular flash suppression, when a checkerboard pattern is presented, and at that time point, when the monkey face disappears from awareness, the neuron could reduce its activity such that it is correlated with the perceptual presence and absence of its preferred stimulus. And this we typically refer to as a perceptually modulated neuron. If its preferred stimulus is presented second, the neuron fires later. Again, the differential modulation that it shows to its preferred versus non-preferred stimulus being perceived is the strength of modulation. Now, with this paradigm and its variants, and with this kind of an experimental design, there have been two questions that have been typically asked by neurophysiologists over the years by doing recordings across the primate visual system. And these are as follows. What is the strength of perceptual modulation that we observe in specific neurons that we record from? And what fraction of neurons in a given region are perceptually modulated? For the next slide, I would like you to keep in mind the area that has been shaded in gray. And in this slide, I summarize research over the last 3 decades of doing recordings across various stations in the cortical, visual cortical hierarchy. So when these experiments were done in early visual areas, they revealed that the proportion of neurons that are perceptually modulated are relatively low, and the strength of modulation is also low. This proportion increases as we go up the visual cortical hierarchy to NP and V4, with 40% of the neurons being perceptually modulated. And in IT, it's almost 90%, and the strength of perceptual modulation is relatively strong. For a long period of time, it wasn't known what was going on in the prefrontal cortex. And we did some recordings using a paradigm similar, as I showed you before, that binocular flash suppression, and found that about 60 to 90% of the neurons were perceptually modulated, depending upon the deep and the sensitivity of the neurons. And the perceptual modulation was actually quite strong. However, since then, there has been a huge debate about regarding the role of the frontal cortex in conscious perception. And here I show you just some of the studies, and this is by no means exhaustive, and there's probably more literature that I've actually missed, but it gives you a flavor of the debate that has been going on regarding the role of the prefrontal cortex in conscious perception. And it has been suggested, and as also the previous spoke of, that no report paradigms are perhaps a good approach in order to address this issue related to the role of prefrontal cortex in conscious perception. Now, the major criticism that has been attributed to the role of prefrontal cortex can perhaps be summarized by this statement from a review from Mr. Koch and others, in which he stated, it has been stated that the neural correlates of consciousness are primarily localized to a posterior cortical hot zone that includes sensory areas rather than to a frontoparietal network, which is perhaps involved in task monitoring and reporting. Regarding the issue of task monitoring, we have previously done a study in which we found that the neurons which fire in relation to the temporal phase of a trial of a task are functionally segregated from neurons in relation to the conscious content during the task. But today, what I would like to concentrate on and focus on is the reporting aspect of this criticism. And by no means we are the first ones to probe actually the prefrontal cortex during paradigms that test for conscious perception. There has been multiple studies in the past. I show you these studies here, but a majority of these studies used actually motor reports, and therefore had this as a caveat. And these studies have probed both the human as well as the monkey prefrontal cortex and different regions of the prefrontal cortex. With respect to our study of binocular flash suppression, even though we did use a no report paradigm, we leveraged an external manipulation of stimulus presentation, which would likely affect the feed-forward sensory drive, which is relayed by the posterior regions of the brain. Therefore, For next, what we wanted to do was wanted to test the neural activity and probe the neural activity in the prefrontal cortex during a no report binocular rivalry paradigm and study if neurons in this region of the brain are perceptually modulated during this paradigm. So what we did is that we did recordings using multi-electrode arrays implanted in the ventrolateral prefrontal cortex, as shown here. We implanted a single array in this region. It allows us to probe from large populations of prefrontal neurons simultaneously. And we combine this with actually a binocular rivalry paradigm. A typical binocular rivalry paradigm involves dichoptic presentation of stimuli such as these, in this case, a gradient drifting up and down present to corresponding retinal locations. When this is done, the subject's perception, and in this case, the monkey's perception, actually oscillates between the two presented stimuli in such a way that the monkey perceives for a certain duration a gradient drifting up, followed by perceiving for a certain duration a gradient drifting down. And the perception bounces back and forth between these two presented stimuli. Given that the sensory input stays constant, but the perception of the subject vacillates, it provides us with an excellent tool for dissociating the neural correlates of sensory input from conscious perception. And we wanted to employ a no-report version of the binocular rivalry paradigm. So can we study actually and employ rivalry for studying conscious perception without a report? And it turns out, yes, we can. What we can do is that we can use an objective criteria, in this case, actually eye movements, for measuring what the subject perceives at any given time. So drifting gratings or moving stimuli typically induce eye movements called the optokinetic nystagmus. These are the kind of eye movements that you make if you were standing at a train station and you were following a train passing by in front of you. I show you here the activity, so the eye movement pattern elicited in response to a grating drifting from left to right. So what the human subject does, it follows the drift of the grating with a slow pursuit and makes a fast corrective saccade. What we used in our experiments are grating drifting up and down. And plotted below is the eye movement pattern, the y coordinate of it specifically, during the presentation of upward drifting grating followed by a downward drifting grating. And as you can see, it consisted of two distinct patterns of eye movements, a slow pursuit followed by a corrective saccade. And using this objective criteria, we could actually deduce what the subject, in this case the monkey, perceived at any given time. And this is what a typical trial during this paradigm looked like. We tried to combine the two attributes of flash suppression and binocular rivalry. It typically started, a typical binocular rivalry trial started with the presentation of a grating drifting down. And as you would expect, plotted below is the eye movement pattern. The activity, the eye movement faithfully follows the motion direction of the grating drifting down. Now, after a couple of seconds, we added a second grating to the other eye, which results in a perceptual suppression, which is reflected in the OK and polarity, such that one observes that the eye movement pattern actually has changed. Now, binocular rivalry ensues in the later half of this period, where there are two stimuli present in front of the subject's eyes, and a perceptual switch can happen at any time. And you observe as deduced from the eye movement pattern, the subject, the perceptual switch happens here, and the subject likely perceives the grating drifting down here. At the same time, we recorded from prefrontal neurons, and here I show you the activity of a neuron that prefers the grating drifting down, as can be adjudged from its activity pattern when the grating drifting down is monocularly presented, during the first couple of seconds. once the flash suppression is induced and a grating drifting up is, even though the grating drifting down is present in front of the monkey's eyes, the neuron almost stops its firing, returning to its firing pattern when the grating drifting down is perceived again during binocular rivalry. Simultaneously, we recorded from another neuron which preferred a grating drifting up, which fires during the period when a grating drifting up is perceived during this trial. So what did the population activity of such feature selective units look like during flash suppression and rivalry phase? So here I'm showing you the activity pattern during physical alternation, which was the control version of our task, and during binocular flash suppression phase of our trial. Like I showed you previously when I explained the paradigm, the activity pattern of the population to its preferred stimulus is presented in black, and its non-preferred stimulus is displayed in gray. Nothing surprising here. The population fires vigorously to the presentation of its preferred stimulus and reducing its activity when its non-preferred stimulus is presented. During binocular flash suppression, the activity pattern is actually fairly similar, suggesting that there is robust perceptual modulation during binocular flash suppression in the ventrolateral prefrontal cortex of the macaque. During binocular rivalry, I'm showing you the activity which is aligned to to switches here in this case. First, during physical alternation trials. In gray is presented the activity of the population when its preferred stimulus is presented first, and in black when its preferred stimulus is presented second. The pattern of activity during perceptual switches during binocular rivalry, when the monkey perceived its preferred stimulus, or as we judged from the eye movement pattern, it was actually fairly similar. So the population activity pattern was very similar as it was during the physical alternation trials. Again, suggesting that there is the strong evidence of perceptual modulation even during binocular rivalry. Now, we did not record from one such neurons, but since we had arrays, we had access to a population of neurons. And what I'm showing you here are sites and the underlying active the sites which preferred either the grating drifting up or the grating drifting down, which are with the preference that is projected onto the array. And we find that these sites which display preference to opposite motion directions are actually distributed in very close proximity throughout the electrode array. Now, given that we had access to all these sites and neurons being recorded simultaneously, what we could do is that we could plot the ensemble activity of these ensemble activity of these neurons during stimulus and perceptual switches, that is during physical alternation or during binocular rivalry trials. So showing what I'm showing you here on the left is actually the activity of the ensembles during up to down and down to up stimulus switches during physical alternation trials in the first row, and in the lower row, the activity pattern actually of the ensembles is fairly similar during perceptual switches. Given this similarity of pattern of responses, it allowed us to actually decode, not only decode whatever the monkey perceived during individual stimulus conditions, but also what we could do is that we could train a classifier on the activity that is elicited during physical alternation trials and test it during the activity that is elicited during binocular rivalry trials to see if the classifier actually generalizes across the two task conditions. And we did this both by training the classifier on physical alternation and testing it during binocular rivalry trials, and doing it vice versa. We did this both before the switch and after the switch. And the chance level here is about 50%. So compared to the classification accuracy that is observed, shown here by box plots from shuffled labels, we observed very strong generalization of the classifier when we trained it on one condition and tested it on the other, which suggests to us that actually the population code that is underlying subjective perception and the one that is underlying is related to the responses elicited to monocular stimulation is actually fairly similar, at least in this region of the prefrontal cortex that we recorded from. For this, I think we are ready to summarize what I've showed you today, at least in this study, is that the spiking activity in the prefrontal cortex indeed seems to reflect at least changes in the contents of consciousness in the absence of any motor report requirements. And in fact, a large majority of sensory modulated units also displayed perceptual modulation, about 85 to 90% of units with a D prime greater than 1. And this proportion was certainly larger than an early sensory area, such as MT, where neuronal activity is related to motion content of the visual input. We could decode perceptual contents from simultaneously recorded prefrontal ensembles during these spontaneous changes in conscious perception. And the strong generalization of the classifier that we observed indicates that there is an invariance in the population code representing sensory input and subjective perception. This work is now published and available in Nature Communications, and there is, I believe, also a link to the paper in the description of the YouTube video. Right. With that, I would like to thank Professor Nikos Liogothetis, in whose lab this work was done, Dr. Panagiotaropoulos, who supervised this work, all the collaborators who have helped with this work. And as was mentioned in the introduction, I shouldn't forget thanking our non-human primate subjects as well. Without their contribution, we would not be able to do any of this work that I've shown you today. And as it was said in the introduction, I'm currently located at the International Center for Primate Brain Research in Shanghai, and where I head the lab of neurodynamics of visual perception and cognition. And I thank you for your attention, and I'm happy to take any questions that you might have.
All right, thank you, Vishwa, for your nice presentation. So we're now open to question and discussion.
Yeah, maybe then if I may start then. Thanks for your great project presentation. I must guess that it's years of the work. That's really great.
Yes.
And I also wanted to kind of bring together with what the first speaker, Yen-Kuang, presented as well. So Yen-Kuang's, presentation included, at least implied a huge individual variance among people potentially, in their behavior during the no report paradigm, right? And in his case, I think the experiment was one shot, right? Each subject came to the lab and then did the no report condition or report condition followed by the report condition. And here, two monkeys, one monkey?
Yes, so we have data from 2 monkeys that we use here today, that I showed you today, yes.
And were they trained in days of the report condition and then followed by the no report condition recording or something like that? Could you give a kind of the schedule of the tasks to infer what's potentially going on? Yeah,
Absolutely. So the monkeys were not trained to report any motion direction or to press levers or to press buttons to report. What we trained them to do is to passively look at the stimuli that were presented to them in front of their eyes on the screen. So the stimuli were presented using a stereoscope. What I should add here is related to the behavior of the animals. Maybe I have a slide and which gives you some idea of the behavior. I did not show this, but if you can see it, is that typically binocular rivalry shows the characteristic psychophysical features that you're probably also aware of is the gamma distribution. That is the duration for which one stimulus is dominant. And we found actually, a gamma distribution which approximated well the dominance time, dominance duration distributions that we observed during binocular rivalry for the two monkeys. In previous work, actually, from Nikos Logothetis and Jeff Scholl, they looked at the correspondence between the lever presses and the ocular following responses, which is shown actually here. And one observes that this is the case in at least more than 90% of the trials for 3 monkeys. So we find at least such perceptual modulation of in case of both monkeys, and we present also data related to the two monkeys separately regarding the decoding of conscious content from their neuronal responses in the paper. So that kind validates and at least demonstrates that we could find similar results across the two monkeys in this case. Yes. But our sample size, as you said, is 2 animals that we have, which is the typical sample size that most of the primate studies actually.
Yeah, for that, I don't have any particular sort of criticism or anything on your specific paper. I also understand it, but the Journal of Cognitive Neuroscience seems to have started an interesting initiative, right, for letting the monkey researchers to publish results with n equal 1 monkey.
Okay.
Yeah, because I know I had a collaboration with some researcher, but the behavior between 2 monkeys was not super consistent. And the rule of the thumb in the field is that if that's the case, you can't usually publish the result, right? But that biases the literature with positive reports, and psychologists, as you may know, have been having the huge difficulty in the replication, partly because this is the publication bias with draw effect. So I think if I don't know whether it's going to happen in the future, but if the people start to make the data available, including these no results, then it might become better at estimating some of the variability across monkeys and so on. Yeah. Anyway, I'll stop to give the opportunity to other people.
Hey, Vishwa, so I have a question. So is it possible that the neural activities you recorded are actually not about conscious perception, but more about the direction of the eye movements or the direction of the attention? So do you have a way to test this? For example, is it possible you can paralyze the eye muscle of the monkeys and still observe this kind of activity?
So we did an experiment actually just to test to actually control for the factor that you mentioned, and it's actually a very, very pertinent issue which we also wanted to address. I did not present that data, but it's part of the paper. Let me briefly mention these results to you. So what we did is that on days that we did these, on some of the days when we did the recordings during binocular rivalry with the monkeys, we also had them participate in 2 paradigms where we looked at the activity of these neurons to ratings presented in different directions. So during 2 different paradigms, fixation off and fixation on in this case. So these are the two paradigms. In fixation off, the monkeys made optokinetic nystagmus eye movements, as you would, as similar to binocular rivalry. During fixation on, the monkeys were trained to continue fixating on a red fixation dot that was presented and overlaid on the drifting grating. And the eye movements were so-called constrained within the fixation window around the fixation spot. We presented stimuli that were drifting in 8 different directions. And shown on the right is the standard deviation of the eye movement signal during fixation off and fixation on. Only the first two box plots are relevant, perhaps most relevant to your question. And what is shown here is that the variance of the eye movement signal is dramatically reduced during fixation on trials as compared to fixation off trials. So this is the behavior part, so how we try to manage the eye movements. To give you a flavor of the responses that we observed, here is example responses of 2 neurons and the polar plots showing their preferences to motion direction during fixation off and fixation on paradigm. And what you can see is that, so this is one example neuron shown in the upper panel, and their responses during fixation off and fixation on. And the polar plot, which displays sort of the direction or the preference of the unit, is actually is fairly similar. So the neuron does tend to respond more strongly here to the grating drifting down. So this would be more like a direction, preferring neuron, and here is more like a neuron which has sort of an orientation preference, firing either to the horizontal orientation across the two fixation off and fixation on paradigm. So we did find quite a few neurons, such as these that I just showed you here, which displayed similar responses when eye movements were present or when eye movements were actually suppressed. Similar to what we did with the binocular rivalry case, we also did decoding of motion content during fixation off and fixation on, as well as what we did is that we tried to train a classifier on activity that was elicited during fixation off and test the classifier whether it can actually generalize and actually discriminate between motion directions during fixation on. For this, what we did is that we chose only the gratings that we used during binocular rivalry, so basically up versus down. These results are actually summarized here, but for the relevance of this conversation, the shown in panel C are actually the decoding results. And we find actually a reliable decoding and generalization across paradigms, fixation off and fixation on. So we can train a classifier on one paradigm and test it on the other. So this suggests to us that at least these results at least suggest that when we codify movements, that maybe the oculomotor aspect that is rightly so tightly coupled with the perception of perception during the task may not be a key factor, at least contributing the responses in this case. So after we control for it, we can still decode motion content in this region of the prefrontal cortex.
Okay, thank you. And there's a question from Yuxin. Yuxin, would you like to speak or would you want me to read? Okay, so the question is just curious whether is there a particular reason why you choose to use vertically moving stimulus rather than horizontally moving stimuli that's commonly used in human OKN studies?
I think one of the reasons is that previous work also, which has employed, at least in monkeys, used up and down. And when at least we tried to do this in monkeys. My experience was that it gave the best, clearest separation of dominance when we used upward versus downward drifting gradient as compared to the horizontal.
I think that's partly because you guys use the coil, right? Eye coil.
So for this experiments, we actually used a camera.
Oh, camera,
So
okay.
Typically, in the past, we used to use eye coils for the experiments. Yeah.
I mean, in
A
human,
camera
I
is
thought that, blink contaminates the vertical, direction estimate, or, lazy eye kind of, situation, especially when, mind wandering or, local sleep happens, eye tends to get, lower. So probably, I thought that may be the reason, but maybe I'm wrong. Can I ask question if nobody else has? Brown.
Yes, go ahead, please.
Yeah, so I mean, so what do you think is the source of the discrepancy between, maybe not only you, but also, Brown and also Yen-Kuang, because now that we have three of you today, so what would be the source of the, at least, apparent discrepancy between the finding of P3B, assuming that this is coming from prefrontal cortex, where what you're presenting is sort of reflecting, which is affected by report or no report, whereas a single unit is not affected apparently. Maybe some kind of discussions on the way forward would be interesting to hear at the floor right now. Maybe starting from Yen-Kuang or Brown, I don't know.
Yeah, I think I would let them take this question.
So now are you asking about whether the discrepancy can be resolved?
Yeah, what's the source of the discrepancy, you think?
Yeah, I don't know, because currently we only tested P3B, and to be honest, we don't really understand the source of P3B in our cases.
Yeah.
So it's hard for us to tell whether this is coming from, I don't know, parietal or frontal areas. And another thing is that, I guess in visual experiments, we are not sure whether the activity you measured is related to P3B as well, right? So I guess it's hard to make direct comparison in this case.
For that, would it be possible to analyze the LFP, Vishal?
Yes, so we have analyzed the LFP in this data, and what we do observe, and that work is also available as a preprint, is that we observe modulations in the theta and the beta frequency band of the LFP. It turns out that we observe theta modulation right after stimulus changes during physical alternation, and shortly after the theta modulation, we observe strong activity in the beta band data. When we check these things during binocular rivalry trials, it seems that that temporally, that these modulations or these bursts of activity are shifted in time in such a way that they are happening slightly even before the transitions temporally during binocular rivalry.
But in both cases, are the activity pattern similar to your single unit or more like EEG? That part I didn't understand. Like, was it affected by the presence or absence of the... you can't actually talk about it because you don't have a report and no report condition.
Yeah, so one is that exactly. So we do not have two contrastive conditions, which is report versus no report, to actually adjudicate this difference. And it was hard to find any kind of stimulus selectivity in the LFP signal in general.
Right. I see. Yen-Kuang, do you have any ideas?
Yes, I just as what Brown just say. We are not we're still not sure where the PCB came from, because in our case, we observe this PCB just happened around the parietal area. So yes, it's still a little bit hard to connect these two studies.
Is there some kind of source localization kind of papers or project going on about this?
You said in our case,
or anyone else?
Yes. So some support PCB came from parietal, and some support maybe they can see P3B at the frontal area. But also some people said P3A, which is a P3 component in front of P3B, came from prefrontal, and PCB came from parietal. So yeah, not consistent.
I see.
Yes.
Is there any comments from the YouTube?
There is one, but it's not relevant to this talk, so I guess that's fine. So maybe I don't know. Is there also like yeah, it's gonna be a bit difficult to do, like Brown's and Yen-Kuang's psychophysics study to measure the appearance of the stimulus under the report or no report condition by monkeys, right? But it would be also interesting to see whether it's possible to do something like that kind of phenomenological report given by monkey under the report condition or no report condition. I don't know how you can do it, but
Yeah, I think it seems relatively hard. I can't think of it right now how one could train an animal to report the phenomenological gradation of its perceptual experience. So I think that would be the tough part, and especially during also no report to read it out somehow. What we do have, of course, is that the eye movement, the OKN pattern, and there is a variance to the OKN pattern that might exist on a trial by trial basis. One would have to first test if indeed the strength of the OKN is in any way reflective of the phenomenological gradient that was being spoken of, and maybe using that one could transfer it to the animals. But I'm not sure. I'm just thinking out loud right now.
Yeah, in terms of the eye movement, I vaguely remember that the neighbor and Frassel did eye tracking experiment with or without report, and then found that the OKN was diminished under the no report paradigm, which is similar to what Yen-Kuang showed overall, I think. Do you know this paper?
Yes, I vaguely remember this one. I think it was this, if I'm not mistaken, loss paper, but I don't remember it exactly right now.
I think it was a PLOS One paper, and neighbor. I think something, probably this paper.
I think it was both optokinetic nystagmus and the pupil dilation that was measured, but I don't remember exactly right now.
Yeah, perceptual level reflexes reveal the gradual nature of visual awareness or something like that.
Yeah, so and another concern I have is related to Nao's previous question. So, because I'm not sure about the history of these monkeys, right? For example, have they been repeatedly trained in other kinds of experiments? So, and if yes, maybe they're automatically trying to link what they perceive to some kind of motor actions, right? Because I don't know, maybe in their past, in their whole life, they've been trained to report using joysticks. So maybe they're automatically having this response, even if you don't ask them to do that. So is it possible to, I don't know, control for this kind of potential confounds from the history or from their experience, past experience?
Yeah. So for these monkeys, I can tell you that they were never trained on a visual discrimination task or discrimination of motion of one or the other direction, or to press buttons or to press levers. So for these animals, at least, we are fairly sure, and we mention also this in our paper, because it's a very pertinent and valid concern, and I acknowledge it as well. Was also a concern that was raised by one of the reviewers of the paper as well, that the past history can certainly have an influence, because we do not know if the animal somehow automatically chooses to start discriminating and planning a motor action, so to say. So we, in this case at least, we are in this set of experiments, we are fairly secure of this caveat.
It's becoming
But one other concern, that has been also seems to be raised a lot, is that what is it? How would the activity change when we go from report to no report? And that I find relatively hard to actually judge, in the sense that if we do end up training a monkey for reporting, then during a no report paradigm, the animal would have this sort of urge to report or planning activity going on in the monkey's head, and that would make it also very hard to dissociate report versus no report once the animal is trained.
Maybe because we are approaching towards the end, I'll kind of bring a bit more speculative or broad kind of stroke, philosophical or theoretical implication of these studies, I guess. Vishal, if you can go to maybe page where you show the implantation location of the brain. Yeah. So that's pretty front, right? And then, so as you pointed out, IIT proponents like Tononi and Christoph has argued that in most of the cases, consciousness would probably reside in the back of the brain. And if I don't know whether that statement is correct or not in all of these situations, and for sure, IIT per se doesn't predict that it has to be always the case. And according to IIT, if the IIT is so-called complex, which maximize the integrated information, includes this part, then that's a part of the conscious experience. And if it's not, then that doesn't, it may be still correlated with the conscious experience, but it doesn't correspond to experience per se. And for that, kind of approach measure that we can look at whether, this part of the brain is included in this so-called complex or not, would be to look at bidirectional connection with the rest of the brain. And then see whether actual integrated information between this part of the brain and the rest of the brain is in fact, recurrent and strong or not. And with respect to the interpretation of the, Yen-Kuang and Brown's paper, if the P3B is originating from parietal areas, then that's also not a big problem with IIT, because parietal is likely to be a part of this complex. So if that doesn't actually yeah, so I'm not sure. Wait, about that I have to think about it again. But anyway, so this kind of issue may be something that I think worth pointing out possibly, even though I probably guess that you won't we wouldn't give any kind of conjecture along this line, but just for fun. If you have any thoughts.
So far, looking at just the rivalry studies, and I would like to go back to this slide. What we find is that, at least using binocular rivalry and its variants as paradigms, we find sort of a distributed nature of the correlates of perception across the cortical visual hierarchy. And it is also graded in nature, it seems, which the lower fraction of neurons perceptually modulated in early areas and higher in later areas. And I think in general, all that the present study does is it adds to this literature to show that prefrontal cortex activity is not influenced by reports, or its prefrontal activity cannot be ruled away just by taking away the reports. And it is distributed. So we do find correlates of perception during the binocular rivalry paradigm in the prefrontal cortex, but you also find it across other areas of the primate visual system. So it's difficult, given this evidence, it's difficult for me to take an either or position of a front or a back of the brain kind of debate that is also relevant to your question that you have posed regarding the theories of IoT, for example.
Yeah, that's true.
So I have one more question for Vishwa, maybe. So, because I think this discrepancy between human results and primate monkey results are not uncommon. Like, for example, it has been shown that, well, we can use fMRI to decode some higher level visual features like color, shape in V1. But these higher level feature selective neurons are less frequently found in primates, right? So I think that's another discrepancy there, and people usually don't understand what's going on. So do you have any ideas or comments about these kind of discrepancy between human studies and primates, like monkey studies?
Yeah. So one is, of course, related to the sensitivity and what the method measures. And as you mentioned, most of these studies tend to use imaging with human subjects. And spatial resolution, of course, is limited of the imaging method. What I would like to add is by showing you this picture once again. So what you're looking at is the distribution of sites preferring one or the other direction over a 4 millimeter by 4 millimeter piece of cortex on each side. So, and all these channels are distributed across this very tiny portion. And what one also sees is that sort of they are so closely right next to each other, at least in case of prefrontal cortex. So one side to another side, the distance is about 400 microns, as you would imagine, because the 4 millimeter by 4 millimeter array. Therefore, a method such as functional imaging, I wonder if it can actually capture such nature of the distribution of feature selective representation in the prefrontal cortex. So that would another thing that I would like to add related to your comment of difference in results that you obtained from what one observes when one does these experiments in human subjects as compared to primates. At the same time, one other thing that I would like to add, there is one classical work also from Alex Meyer and others, which employed similar paradigms and studied in the monkey functional imaging with functional imaging and also electrophysiologically, and found compatibility in the sense that the functional imaging results in the monkey were similar to that what one sees in the humans, and electrophysiological results for what one has or one always found using monkey studies, which was sort of putting it together that it is not, at least in some cases, at least this case, it's not a species specific difference that in case of monkeys and humans, but it could perhaps be a methodological difference that one the methods that one uses for studying the human subjects as compared to monkeys.
Yeah, but that's a really good point that, it's an outcome of this today's, seminar. I think that what we lack is like monkey version of the EEG and also fMRI, and that contrasts report and no report paradigm, right? That's clearly lacking right now. And it's plausible based on what you said exactly. I totally agree that with Alex Meyer's finding, it's highly plausible that with the fMRI version of the monkey, report versus no report experiment, they may also diminish the prefrontal activity in terms of the bold contrast, but not at all in terms of the single unit, right?
Yes.
That would be completely, close the circle, I guess, But what it means is still not clear. I also wanted to make one comment about this. So it's a bit difficult to make an inference from this alone, but if you were to show something similar with the same scale, but in, let's say, V1 or V2 of the monkeys, then you would expect that the transition of the preferred direction to change gradually over the angle, right? And if you were to do that kind of mapping of the preferred direction within this area, do you also see that kind of ordered topological relations in terms of angle as well as a spatial preference? The reason why I ask is that it's kind of relevant to the IIT prediction. So what IIT predicts is that if the as within the early visual areas or sensory areas, they tend to be connected with the neighbors, right, of the neurons, which shares the receptive field and also shares the preferred stimulus property, and also it also shares the spread of the feedback axonal terminals from the higher areas and so on. So that promotes the, in a sense, generating higher and higher integrated information, because each of the neuron is connected to the neighbors and also back and also above, below and above hierarchy. It's very difficult to disconnect this thing into, separately modulated units. On the other hand, their conjecture about why prefrontal is not really generating, or related to consciousness is potentially that any given neuron within prefrontal cortex does not have a common input and also common output shared through the lateral connections as well as a common target and common feedback source. I don't know whether this is actually true or not, but from this type of the preferred direction mapping, I can imagine that could be the case, but what do you think?
So I think your question is twofold. So one is the fact that there is certainly much more topographical representation of the visual input in early visual area. And there is literature also starting from Hubel and Wiesel and also other people who have done similar studies looking at the columnar organization
Yes.
of the visual areas. Now, in context and in relation to the prefrontal cortex, there is some literature which suggests that there are these anatomical stripes that one observes in the prefrontal cortex, such that there is connectivity across between 3 to 7 millimeters distances within the prefrontal cortex neurons. And the work from Goldman, Patricia Ricci on working memory in the prefrontal cortex, when she did this work, she suggested that perhaps these stripes that one observes within the prefrontal cortex might be mediating the reverberant activity which sustains working memory related sustained activity that one observes during these paradigms. So there seems to be at least some recurrent activity. There is work that we've also done with Utah arrays looking at the structure of spike count correlations across these sites. And what is interesting, at least and different from primary visual areas here, but this is a direct comparison to, this is in direct relation to the question that you posed, is that when you look at the structure of spike count correlations as a function of distance, it seems to reduce as a function of distance in early visual areas. That it tends, that seems to be the general finding.
So the closer neuron tend to be correlated in the early visual areas.
And functionally correlated as judged by spike count correlations or these noise correlations
I see.
one calculates. When we do similar when we did similar work and looked at such correlations, in case of the prefrontal cortex, this is we found that sort of neurons so we found a U-shaped structure, the spike count correlation, which would suggest that, you know, after a certain distance, the spike count correlations tend to go off, which might be reflective of anatomical connectivity as well. But you cannot say 100% for sure, but at least functionally, one can, from the electrophysiological activity, one observes that.
Well, was the correlation generally similar level between RE and the PFC, or was it more stronger in one area than the other? Overall,
I don't remember the exact values of correlation that one observes in the primary visual, primary sensory areas, the visual cortices and the prefrontal areas. This is the work by Safavi, Dwarkanath, and others, and I contributed to this work as well, where we published in PNAS, where we looked at spike count correlations across distant nodes as recorded with the Utah array. The exact number comparisons of the strength of correlation in prefrontal versus B1, I don't remember the values.
I see.
But the nature of functional connectivity seems to be somewhat different. Yes.
That's very interesting. Great.
Okay, so I guess, well, if there's no more questions, let's thank both of our speakers today again. And now I'll give it back to you if you have any conclusion or announcements to make.
So there will be another. Thank you. First of all, thanks for the both speakers. It was great. I learned so much and enjoyed, as usual. And Next consciousness talks will be held on May 3rd on consciousness and anesthesia. And the speaker is Katja Valley and Rob Sanders from Australia and also Finland. And then one after that will be May 25th on sleep and consciousness, given by Jenny Wint and at Monash and Masako Tamaki at Riken. That's it. And I'll stop streaming. Thank you for the YouTube participants. Bye.
Thank you. Bye bye.
Yeah. Now I